All right, so any raise of hands first in the audience? Who knows about Viam modules? Who knows what they are and has like tried deploying them before? Just throw those up in the chat. Sorry, y'all. You can put a question mark if you've never heard of them before. Cool, Dan. Great. All right, Aaron, thanks for letting me know. Matt's still thinking about it. All right. Cool. So today we're going to be talking about those modules and models and everything that they are and how powerful they are for sharing and extending and making the best machines and robots you can make. So for those that don't know me, my name is Nick Hare. I'm a senior dev advocate at Viam. I've been tinkering and working in home automation and embedded development for 5 or 6 years now, mostly in open source, a lot of JavaScript, and getting more and more into a lot of the robotics and other machine learning and edge AI sort of stuff here at Viam. You can find me on socials, on GitHub, and everywhere as at Hipster Brown. So if you see Charlie Brown with a mustache and glasses, that's probably me. So for those who haven't heard of it, the Viam Registry, we have Viam as an application. It provides a lot of great capabilities by default through the Viam server and what we call the Robot Development Kit or the RDK. And it allows you to do quite a bit out of the box, control cameras and motors, of all sorts of capabilities, upload and use vision services with machine learning models, and capture data, train models and everything. But what happens when Viam can't support all things for all people, and there's something that you really want to work and you want to be able to use it with your machine? Well, that's where the registry comes in. It allows not only Viam, but anyone in the community to share those sort of capabilities by extending those built-in components and built-in services, creating a similar API, and allow it to seem like it's something that's just included in the platform, but is provided by you or your organization or anyone in the community to make better machines. And the list of available models, ML models, and modules are located at app.viam.com/registry. Now, another way to discover modules can be the docs.viam.com/registry, where you have a nice interactive search, which will be coming soon to the main registry page for browsing. And it allows you to look up, maybe a keyword for a machine learning service or for a particular integration that doesn't exist by default, but you think would be really helpful. So you can see some of the lists off the top here around RP LiDAR, with ROS2, and we have ones for enabling RGB LEDs and local LLMs and speech to text. And so these are all available publicly, and a lot of them have open source code for you to go and view. And so when you select a module from the registry and you want to view the details of it, we can see here, like the motion detector module, it provides a vision service for motion detection. And we can see how it implements the vision service. The model is called a motion detector. Its latest version is 0.1.6, published on that date. We can even view previous versions if you want to see how often it's updated and how often they're rolling out support, just like you would for a lot of other dependencies within some of your programs and in Python or JavaScript or anything. And we can see all the supported platforms that it's published for before. Sometimes you might see private modules if your organization or you personally are publishing modules for sharing across all your different capabilities and all your different robots. And you can see the usage across all of Viam. So if this is a public module and you want to see if are people actually using this, is it in production and working well, this gives you a good indicator for that. And then, of course, there's the option to include a link out to further documentation, whether it's a GitHub page or it's a custom documentation site. You can go and see what sort of example code is available, how to configure the module, and any other details that might need to be read about before setting it up for the first time. And I mentioned a bit briefly, but machine learning models are also available in the registry. This is somewhat recent, and you're able to upload pre-trained models that you trained yourself in Viam or you found on a site like RoboFlow or Hugging Face, and you want to be able to share it with your machines or other machines for, again, the whole community. And so you can discover those from the docs page as well, and see we have various detection models, emotion detectors, and you can view into the further details for those. And here's a pose estimation model that is built for TensorFlow Lite and has the ability to detect objects, and in this case, detecting the pose of the image passing through the vision service. And so we have a PoseNet TF Lite is the file that will be downloaded, what the size is. So if you have a size constraint, you can decide whether or not it's worth to download that and keep it as part of your machine configuration, and a brief description about what is this supposed to be doing and what is it identifying for you. You could also include maybe potential labels to look out for in this description, and link out to that. All right, before I keep going on this, how are we doing in the audience? Any quick questions for me to reiterate before I keep going forward? Everyone, understanding where I'm coming from and where to go and learn a bit more about what's possible. Great, thanks, Dan. Thank you, Ariel. I'm so used to a lot of meetups and conference talks where you have that great engaging audience. I see all the people on Twitch streaming all the time, and it's getting used to the presenting and the delayed feedback along the way. So when you find a module that you want from the registry, how do you go about uploading it and deploying it to your machine? So in your config tab for a machine that you have ready to go and you've been configuring before, or you're starting from scratch, you can go and create a component or create a service and search for that module name, or go into and explore the various modules available from the registry for each different component or service from the app config or the machine config itself, and then add that to your machine config. So I'm going to share a different window. So we can see here I have the candy bucket, Halloween candy bucket project that I did last year. And we have our typical components of a board, a camera, as well as here I actually have a custom module for RGB lights. And so if I wanted to add this again, just remove that. And so I can go and create a component, and maybe I don't know what the actual component type is. In this case, we don't have a built-in RGB LED component. But if I want to search RGB, I can see we actually have a couple. There's a RGBD overlay camera provided by Viam from the registry, or one from me that supports the WS2801 programmable RGB lights. So I can see here that it contains this WS2801 model in here. And I can see it's used by 4 orgs, deployed to 4 robots. I can see also that homepage URL link from before that takes me to the GitHub for it. And I can see it supports Linux ARM64. So I can go and add that module in here, name it, like any other component or service I would name. In this case, I'll just call it RGB. And we see it's added here, and I have the ability to configure it using various attributes. If I go into my component documentation, I can see the module configuration takes a couple different fields, like a clock pin, a data pin, the number of LEDs, and maybe configuring a default brightness. And sometimes this will be a, formatted JSON block. Sometimes it's a more descriptive layout here. Depending on who's authoring the module, it can vary from, GitHub to GitHub. And so if I wanted to configure here, just like with any other sort of raw JSON, I could do my clock pin, maybe it's pin 3, data pin 4, and then number of, what's it called, LED count. Let's say at 10. And then I can hit save. And as with any other configuration change, if I had a live machine right now, it would go through and download the module code from the registry and start it up and connect it to Viam server. And then I could start seeing in the logs any feedback from that module as it's running, whether there's errors or info or anything that I need to worry about. Great. And we actually can see the various deployed modules from the modules tab within the Viam machine details page and configuration. And so that will give us details, again, about the actual module being used. In this case, it's showing an example of a RealSense module being deployed, and also if any updates have come through and how you want to auto update your modules in the field or when they come back online. And so in this case, it will take any patch version and auto deploy it. But you could say a minor version, which would be that second number in the series. So if a 0.1 version came out, it would deploy those, but not all patch versions or all major versions. And so you can allow that to be an automatic thing or manually update the version yourself as you want to slowly roll them out to various machines you have in your fleet or in the field. All right, so we're about to go into the details of building your first module. Before I continue with that, again, any sort of questions about deploying, configuration, before I continue on? All right. Ariel will let me know if anything else comes up in the chat while I'm continuing forward. And so there are times when, the Viam module has only been around for Viam registry, has been around for less than a year. So obviously it's not going to cover everything for all people. And sometimes you need to make your own, or someone in your organization needs to make their own and then share it with the rest of the team. Especially if it may be using proprietary hardware or your own algorithms. You want to keep that within the organization and you want to keep sharing it. or it's something that's interesting to you. Maybe you thought you could improve upon some of the built-in components and you want to keep making it available for everyone else, or making integrations for other things. Like we have RoboFlow integrations and others to allow you to use external services to maybe train something and deploy it and control various bits and bobs for your machine. And so before we dig into exactly building out your first module, let's explain a little bit of the terminology that we use in a lot of our documentation, and it's a lot of M's going on. And so a model is what we call a particular implementation of what we call a resource. And that model, like I was showing before, in the case of the RGB LED, was the WS2801 implementation of a RGB LED light. And so that would be my model that I created, and it implements all the things that are necessary to be what we would call an RGB LED as used by the machine or any sort of programmable code that wants to call into that module. And a module itself is a package of one or more modular resources with an entry point that would, that's how the Viam server starts up a model and enables it to, speak to the RDK and control parts of your machine. And then, of course, a modular resource is a custom model of a component that implements the standardized API methods of that resource. And we'll get a little bit into the details and a little bit around that. And so you'll see these various words sprinkled throughout documentation, and hopefully that helps explain a bit more, or as I'm going forward, what I'm talking about when, the fact that we have ML models or machine learning models within the registry, and we have another thing called models, can get a bit confusing at times, even for myself. And so just want to make sure that's clear, hopefully going forward, and we'll reiterate on it as we progress. And, you'll see that throughout some of our tutorials too. And so, maybe you had an idea, again, like the RGB LEDs, for example. We've done stuff with different types of cameras. And so implementing a camera means choosing the camera API components or camera component API and viewing those different APIs in order to decide, okay, I have to be able to implement these various methods as part of my model. And let's show off what one of those looks like now. So if we go into, check out our APIs here. So before I said camera, right? And so camera, the camera component itself has different methods you would call into. And those methods can be defined on a Go struct, on a Python class, C++ class, depending on how you're implementing it or what type of integration you're creating. And so if we look at these various methods, like a basic getting started for any camera really is how do you get an image from it. And so our documentation shows the sort of type signature that we're expecting from that method. So in the case of Python, we have a MIME type argument parameter for string, and it should return one of these types to come back from it. In Go, we have a context and error handlers, and it would return looks like a Go stream video stream. And you can look into our different SDK docs to learn a bit more depending on what language you're using. And you could have the option to not implement all of it. Ideally, you'd want to implement every single available method as you can, but you can also choose to say this is not implemented for this particular component and documenting that so that folks consuming your module know that okay, this supports get images, but maybe not point cloud because there's no available way to say like there's depth to this image or any sort of like way to identify a point cloud for this particular component or hardware. And so we can identify all sorts of APIs, and same for services. If you wanted to implement a motion service or a vision service, you would just need to know how to, if it's a detection service, then you should implement get detections. And another thing, if it's a unique functionality that doesn't exactly fit within any of the component APIs, you can choose to make what we would call a generic component or generic service. And this is actually a sort of base class or base implementation for almost all of our components and services. So it provides a simple, relatively simple, single method called do command. And so this is a very flexible method that allows you to pass in the name of a command and any sort of argument you want to pass or parameters you want to pass off to that command. And so in this Python example here, you can instantiate a generic component and then pass through any number of a command itself and any of the parameters you want to pass through that command on the underlying module implementation. We can see the same for, again, Go or C++, and this is the most flexible way to try out maybe some custom functionality without having to go all the way into what we would call custom APIs, which have a whole nother sort of presentation that we may end up doing later on. And so getting started with the actual coding part of your module, once you've identified what you want to implement, we have a early version of a project generator. So if you go to github.com/viam-labs generator-vm-module, it uses a generator utility called yeoman. And so that's that yo front CLI. And so if you go yo VM module, it'll help scaffold out an initial like Python module for what you select. So in the case of the GIF that we can see here, we can see that it's implementing a new sensor. That's the name. The name of it is called my new sensor. We're going to put it under the namespace Viam Labs, and then it will generate the boilerplate of a Python package along with a main program and an entry point for getting started. But you can also choose to manually set up your own project if you're experienced with building out a new Go module or a C++ project, and then make sure that you have, pardon me, one second, and make sure you have the implementation code and the entry point, which we'll talk about a little bit later. But I recommend if you're experienced in Python or just want to get started, the module generator is one of the best ways to do so. And so an example implementation usually can be found in any of our SDK repositories. So I have this class that I got from the VM Python SDK under the examples directory and simple module. It implements a sensor module, and calling it VM sensor my sensor, just again as an example, not quite pseudo code, but something somewhat practical enough for you to hopefully see where your code would go in creating your own version of this. And so in this case, if you're experienced in Python, this might look familiar to you, but the basics get started with a new class method for instantiating your module, and then you can have a choice to validate any sort of configuration that it accepts. So that way it doesn't try to start up the module and then fail at runtime. It'll give some early warnings within the VM logs to say, oh, this was incorrect. You should fix it this way if you provide some good exception descriptions. And then for a sensor, one of those key methods is that get readings method. And in this case, the get readings is just returning, 1 times a configured multiplier. And then we see that do command again as the base implementation. It doesn't actually need to do much or anything at all because get readings is the core part of the my sensor. Pardon me, the my sensor model. And reconfigure is called anytime any configuration changes or the initial configuration and any reconfigurations after that. If they change, and you want to change how it affects your model. And then close is called when the VM server is shutting down and needs to clean up any resources that were created before. And so before I mentioned an entry point, and an entry point is what the VM server will call or execute when getting started to create the process that it's running for your module on your machine. And so in this case, this is part of a Python program as the entry point, and it uses some classes from the VM SDK for Python to register what we call a resource creator. In this case, it's a sensor resource. We're using that model from the mySensor class, and then we are registering it with the sort of internal VM registry within the VM server. And we can see us using those class methods off of our mySensor class in order to register that. And then the module will accept what we call it, a sort of link to the as an argument to the command line process, a link to the VM server so they can talk to each other and monitor the various life cycles of the module. And so once we add the model from the registry, we start it up, and then we can start seeing logs coming from the Viam app as well. And so once you create your initial version, you're like, okay, I think this should work. This matches, the expected APIs, and I want to make sure it works on the actual either the device itself or maybe your laptop or maybe you're programming on a device like a Raspberry Pi already, and you want to test it out. And so there are a couple ways to do this, and we describe them in our documentation as well. But the basics go about setting up your dev environment, like your laptop, because you can run VM Server on Mac OS or Windows with WSL, which is Windows Subsystems for Linux. You can run VM Server on your laptop with a configuration for your machine. Pardon me. And then you can configure what we call a local module, which I'll step through in a minute, and then create a local component or a local service for that module. And then monitor logs in the Viam app, and then restart anytime you change the code and rebuild your module. And it's very similar on the remote side, except that you need some way of syncing your module code from your development environment onto the device. You could do something more manual like the SCP, which is like copying files over SSH onto a device. Or you can use a more automated approach like Mutagen, which we document in our documentation site. And then the same sort of steps are there. So if you have your test device as a machine on Viam App, you point to that synced over module code as a local module, create a local component, local service, monitor logs, and then restart the VM server anytime the code changes that you've done the sync over to your device. So let's step through that real quick in maybe like my Candy Bucket example. So in the modules tab, we can see there's the option to add a local module. And so let's say I wanted to be able to speak to my Candy Bucket, and I actually have a local module that does speech to text right now. And so I can let's call it SDT for speech to text, and then I can point at the executable path. So this executable path is actually the entry point for the module itself. So this is what VM Server would call. This is what we will call in our module code. And so let's pretend we have it at something like user. So if it's on my laptop, hipster brown source SDT vosk, and then run.sh. So I can walk through some of the code that I have for this module in a minute, but in this case, it's going to execute this run.sh file located on my system, and I can name it here, and then go into, it's called a service. So I'm gonna create a service, and we can see here local, but if I needed to search for it, I could just go local service. And the type for this one is actually a custom type, which might actually not work here. Anyone in the chat is available to give me some feedback on this one. I think I might have to create a basic type and then change it in the raw JSON. I zoom in a bit. How's that? Yeah, in this case, Dan, generic type, it's not a generic API, it's actually a custom API, which makes things a little bit different. For this case, the triplets, I'm actually going to go view that now. Those that don't know, the speech-to-text VOSC or SCT VOSC module was published this past week and allows for local speech-to-text on your devices. And so I can check my triplet here, which I believe should be this. Or it might be my model, actually. There we go. And we're just going to call it. Oh. Yep. And I'm going to go into my raw JSON here. And find type. I think I want this to be speech. Viam Labs. So yeah, so this would be the Viam Lab Speech SCT VOSC, and it would then execute my code that I have configured, that executable path for my local module. And then anytime that I wanted to change that, I've sunk the code over, or I've changed some things and rebuilt the module on my laptop, I could hit restart, and then it'll reinitialize the whole VM server, including that module, and give me any sort of logs and feedback, and I could track that within here. So once you've tested it and made sure that it is actually working, you can use the VM CLI to then create your module. And so you get started by actually calling the VM module create command with the name of your module, and then the public namespace. And so that public namespace can be configured within the VM app. And so I can actually see, hopefully no sensitive data. I can see my public namespace here as, and then, so each owner of their org will have each org I think will have only a single public namespace. And you can use that as a shorthand rather than having to memorize your organization ID completely. And with that namespace, you will then, the VM module create will register the module with the VM registry, giving you a boilerplate page on the VM registry right away until you're ready to actually upload your first version of your module. In order to fill out all those details I described before that lists on the VM registry details page, you would fill out the created meta.json file within your project directory. And so that meta.json, your module ID should be automatically filled out for you based on the arguments that you gave the VM module create. So that namespace would be here, colon, and then the name of your module. The visibility, so you can change that to private or make it public. I do believe once you made it public, I'm not sure if you can make it private again, something to check out if that question comes up. The URL to further documentation, most likely a GitHub repo, if it's an open source module. Any sort of description you want to include. And then again, the implemented models that are contained within you or within your full module. So for the most part, you'll probably see a lot of modules that include only one model that's implemented. There are some that include multiple. And so in this case, this example is showing it as a generic component API with a model called, your namespace. It's usually your namespace, what that resource is called. So in this case, it might be, hipster brown generic my model. And then again, that entry point or executable file that was located, or binary if you're building a Go or C++ project. And then finally, you can then upload your module. And so whether you're building out the binary for various platform versions, if you're writing it in Go, or if you are going to tarball or bundle all of your code together in the case of a Python module, you can do that and then call upload with the version of your module. So that could be, again, you could just call 1.0 or like 1.0.0 or a 0.0.1, usually what I start with because I'm not sure exactly how stable it's going to be right away. Name what sort of platform that you want to support or number of platforms. You would call this multiple times for each platform you plan to support. Or you can say platform any in order to support, say, like it's going to work on anything that VM server runs on. And then a path to your module. So in the case of something like a Go project, it could just be that binary that you built. In the case of Python project, it could be that tarballed or that bundle, like a tar.gz file that contains all of that together, which would then publish it and upload it to the VM registry and allow you to then see it publicly available or private if it's within your org on the VM registry. And then you can go and deploy it like I was showing before, like any other published module. So I know that was a lot. Let's see, we have a couple questions now in the chat. I'm going to stop sharing my screen for a little bit. All right, so Dan says, can you change the API type after creation and publishing it to the registry? That's a good question. So we have the ability to update using the VM CLI. So I believe if you want to update that part of the meta.json, let's see, let's find the VM CLI. So module. So if you want to update your existing module on your local file system with recent changes to meta.json, then you would call update. And so that any update to that configured API type, you should be able to call VM module update, and then that would change what it's matching within the registry. I don't think we put any limits on that at the moment, but one of my team members could probably correct me. Professor D is asking about support for microcontrollers other than ESP32. So nothing solid as of yet. We're really working on stabilizing support for ESP32 to make sure it's as ready to go as any of our other single board computer support for the full RDK, and it's coming very close. And I think once that's in place, there might be some more explorations around some other popular microcontrollers as we see, interest from the community. So like Professor D, if there's ones that you're really interested in, let us know. Start a discussion in the Discord. We can run it up to the MicroRDK team and see sort of what bandwidth we have there. And Dan, it would be good to see examples of multiple model modules if anyone has any to share. So yeah, we have a couple in the registry. If we go, again, looking real quick at what's available, I believe Michael Lee is one of our more prolific module authors, actually has a few. So he has a generic or like an all-encompassing sort of monorepo of a lot of modular resources. In this case, we can see that here. I'll paste this in the chat. That he's implemented, 4 different models, all following that generic component API. So implementing an 8-segment display, how to play a file, and this was, I think, one of our earlier sort of modular resources available. And so, you can see him implementing a lot of stuff that may be available as like its own individual module now. So I know, for example, we have a audio out module implemented by Matt Bella. And so that could be replaced by the audio out module, and which has its own custom API. You can implement more than one audio out resource for that. And this is structured, again, like a Python project. And we can see, let's take a look at that meta.json again. So we can see we have an entry point here, which is a dist main, which means he's probably building the Python wheels or a Python compiled version of Python in order to run that. We can see that module ID, and actually this build configuration is fairly new. We have the ability to actually build your Go or Python modules in the VM Cloud service. So if you don't want to worry about building it for multiple distributions or running, and you want to automate this, once you push up or upload your module, it will build that for you and include that as part of your registry, your module registry, when pulled down to your device. And so, again, looking at some of these entry points, we can see there's a main and the very models in here. So main is what we were seeing before for like the entry point of, creating the resource creators, registering these various models for the generic subtype, and starting it all up all at once. And then all the modules are just thrown together in here as implementing, a generic component and implementing that do command we were showing before. And so this is a good example of showing like how flexible do command can be to implement all sorts of different pieces of hardware or services. And now that we have a generic service and generic component, you can kind of semantically group those things a bit better than before. Any other sort of questions that I can cover? Dan, something else Matt and I are discussing. Is there a mechanism to allow inter-module communication in ROS topics? Like run different Python processes like pub/sub can communicate modules. Yeah, that's a good question. There's nothing built into the VM module system at the moment that would provide that by default. So either, I've discussed this with some of the people on our development experience team, and on device, not really. For something like, if you didn't mind including something like Google PubSub or a system like that, you could rely on that. Otherwise, Matt and I have been working on communicating with the module development team about using custom APIs and be able to pull those in to communicate across devices. If they depend on each other, you can somewhat use that, but I'm not sure about modules. One module depending on another module, it also depends on it, like a circular dependency, and how well that communication would work at the moment. Some testing would be needed. Yeah. So it's definitely top of mind, especially Dan, as you bring it up and we discuss with them the best architecture for that. All right, we have, is there any tutorial document that involves all the steps you discussed following? Implement something, the whole process gets started. We have the documentation in the docs site, a series of pages about all the steps that I described before, including example code for Python or Go, and how to, and C++ actually, and how to go about, finding, the module API, start implementing some of it with some example code. And again, the various SDK repos have further details than the documentation site themselves have. We don't have a video at the moment around that, but I do think Matt Vella has been exploring how to go about creating a custom vision service as an example, to help folks realize, like, hey, here's how you maybe take a visual language model or a different sort of visual machine learning model out there and combine it as a vision service. Thanks, Dan. Appreciate that. Yeah, the module system has been very interesting to explore since I started at VM last year. It was just before the modules were a fully public thing and available for anyone to author. And so there's been a lot of good feedback from, both internally and externally to see how we can continue to improve it, where some of the sort of edge cases were originally, and continue, again, like we said before, the machine learning models are a new addition to the registry. So we'll continue to extend it and make it more useful for developers on VM. And it's kind of amazing to be able to see, like, oh, I want to provide, again, like I was saying before, speech to text as a local functionality for my machines. And so, I knew that there was a model called Vosk out there and in a library. And so I wrapped that in a custom API, and I started with actually a generic service because that was a great way to get started. And made that so I could start, speaking to my robots and getting text back. And then I'm looking at all these other opportunities to be able to compose together, again, these various bits of functionality, and not have to do everything in one monolithic program, which makes it harder to update over time or share different pieces with my various machines. And another advantage we don't often talk about maybe around modules is since you can control a module from any of our SDKs. And so when you use a generic service or use a camera, talking to that module then from the Python SDK or the Go SDK is just implementing, instantiating a camera from robot and then the name of your module. And now you can get images and everything from, or even from our TypeScript or Flutter SDKs, you can start to communicate with modules on devices. Whereas if you wanted to get that custom functionality using TypeScript or Flutter before, it wasn't easy or wasn't obvious. Like with Python, you might be able to deploy your program over to a device and then you're, kind of hand rolling some, services or hardware controls. But by wrapping it in a module and making it easy enough to share, it means that you can now control it from almost anywhere, whether the program you're writing or your control code runs, again, on device, in the cloud, on a different sort of client like the browser or a mobile device. It's very, very incredible. So we have about 5 minutes left. Any other sort of last minute questions? Any sort of things that you all want to see as sessions over the next month or future sessions, even after the community challenges are over? There's been good feedback around things that we can improve. There's been good feedback on some existing educational content that we can include later on. But I'm excited to see what you all build. And please share any of your modules that you all are building after you publish them. Share them in like the Built on VM channel in Discord or under the Challenges channel as well. We just want to make sure we're making the right content for you all. Make sure that we're helping you solve any sort of friction or problems that you're hitting. Just see a couple people chat, a couple people typing. So I'll wait until we get those last questions in, and then we'll probably sign off. I'll see you at future events as well. Our next one is going to be with Matt Vella talking about making smarter cameras, which will be very awesome to again see about integrating custom vision services and all sorts of machine learning models together. And then I will also be back for the how to use computer vision in the Viam app itself. Was wondering, rather than downloading the model like Gemma, can we just send the data to the API and get back the results? Yeah, of course. So a service within Viam, like as a module, we have like, for example, the speech module that we have available defaults to using Google's speech to text, text to speech APIs, and so you can configure it to with your API keys and everything within the Viam app. It can also use OpenAI's ChatGPT 3.5 or ChatGPT 4 as like a LLM to communicate with and get completions back. And so we have examples of how that would work. And so if it's Python code, it doesn't have to control anything on device. It could be using to talk to a remote database if you wanted to. It could be talking to any sort of remote service like that in order to provide extended functionality for your machine. So we can include a link to the speech module as an example for that. And something that Matt and I have both been working on is allowing for more composability of modules together from even other custom modules. So kind of layers on layers on layers. So the speech module has recently been extended to allow you to use that STT, VOSC, or any other speech module as a dependency for running locally rather than on a remote service, depending on your requirements for maybe latency or offline ability. And so you can see how that type of stuff is configured within a module like the speech module itself. Awesome. Well, thank you again, everyone, for joining. It's been my pleasure to kind of share some knowledge and to hopefully you all go away with learning a little bit as well. And I will see you in the future on Discord or other live events. And happy hacking.